Hey, welcome back. Our next method to implement is pop. So just like on an array, a pop, when we call pop, it removes from the end of the linked list. It takes the last item on there, the tail, and returns it to us. Now that seems simple because we're keeping track of the last item, the tail. So we should just be able to return it. The problem is, to remove it, we have to assign a new tail. And that involves going all the way through the list from the beginning because we don't have a backwards pointer. We can't just take the tail and say, give me the one before this. That's not how a singly linked list is set up. If we look at Visual Algo again, if we try and pop off of this, we just say, take the last item off. Well, we have the tail. We know it's 90. I could give you the last item very easily. But to then update the tail here, otherwise we're not actually popping it off. We're just getting the last item. To move the tail here, we have to start at the beginning, go to the next, and go to the second to last item and make that the new tail. So if we insert, let's walk through this. Or no, we're not inserting. Let's remove. We want to remove from the tail. So that would be popping. We go to the second to last item. All right, so we found it. Let me slow this down a little bit and rerun this. If you want, you can look at that code on the right, but I'm going to walk through. Let's go step by step. Okay, so we start at the beginning. We go to the next thing. That's not the end. And we have two variables because we need to keep track of the second to last item. And how do we know what the second to last item is? Well, if we have the first variable and it hits the end, so they're sort of like offset by one node. So we have this one variable called pre or previous node or second to last, it doesn't matter, or new tail. And that's going to keep track of what we're actually going to set the tail to be. And we're just trying to find the second to last item. Okay, so we have now found the second to last item. So we remove 85, and all that means is taking this item dot next, setting it to null. That severs the link. And then we take this and save it to a variable so we can return it. And then we set this to be the new tail. Does that make sense? Hopefully. It's a little more complicated. And I'll walk through the pseudocode, but the first thing that we have to be able to do is traverse our list. So to traverse it, it's not that bad. All that we do is start at the beginning using the head, and then we can loop and keep going while there is a dot next. So this isn't the solution, but if I wanted to make a method called traverse, all that we would need to do, let's say I just wanted to print out every item in the list. So we're going to start with a variable, let's just call it current, if I can spell, equals this dot head. So we start at the beginning. And we can do a while loop, a for loop. You could use the length and do a for loop. I'm going to do a while loop and just say while there is a current, just like that, we're going to say console.log current.val, and then we need to update current equals the next off of current. I keep saying, does that make sense? Probably not. It's confusing. So we start at the head. If we have hello, goodbye, and let's do exclamation point at the end, like this. If we start at the head, we're going to set current to be this node, hello, and we're going to console.log hello. Then we're going to change current to be current.next, which means it's now goodbye. So the loop starts over. This is still true. So we console.log goodbye. Now current is current.next, which is exclamation point. It starts over, still true. We print exclamation point. Then we set current to be current.next. There is no next. It's null. So this loop now is done. And if we tried running this, I do list.traverse. Oh, I have 3 hours. Hopefully you saw that before me. Try this one more time. Rerun it, and we do list.traverse again. All right, so we get hello, goodbye, exclamation point. Nothing's returned, so we get undefined. So that's one way of traversing a list, and we're going to need to do something like this in order to figure out the new tail. Now there's a slight distinction, which is we don't want to get all the way to the end of the list. We need to get to the second to last item, and we don't need to print anything out. So I'm going to actually comment this out. We're not using this in our code. I just wanted to show you one way of traversing. Okay, so if you want to try this on your own, first thing you need to do is define, I didn't add this time, define a function called pop, and it doesn't take in any variable or any data, right? It just pops the last thing every time. If there's nothing in the list, nice and easy, return undefined. So you could check if there's no head, or you could check if the length is 0. whatever metric you use, return undefined if it's empty. Otherwise, loop through the entire list until you reach the tail. But it's not that simple, because what we're actually doing is trying to get the thing right before the tail. So loop through until you get the tail, but also have a variable that keeps track of whatever the last item was, like we saw in Visual Algo, where well, this is a bad example. If I go back, can I go back here? Here we go. So we have two variables, and we're getting to the end with this one called temp, and then pre is always it's lagging one item, one node behind. That's going to give us the second to last item once temp hits the end. All right, so we just set the next property of the second to last node to be null, and then update the tail to be that second to last node. And then we subtract 1 from the length and return the node that was removed. So that is important. You need to store it in a variable so you can return it. Okay, so that's pop. This one actually, push is pretty straightforward. I think pop is one of the trickier ones. Some of the other things we'll see later on are actually easier. It's just that push and pop go together, so I felt bad about splitting them up. Anyway, give it a shot. Don't feel bad if you get stuck.